The intensity of light d meters below the surface of the sea can be modeled by the equation I equals I naught E minus KD. Divers found the intensity of light is halved when a diver is 5 meters below the surface of the water. Okay. Find the value of K to 4 decimal places. Okay. Now, a bit of a hard question here. We've got to think a bit laterally. What we do know here is the distance equals 5. What we might do, I might just copy the equation across here, so it's in our site here. So just copy this across. Take a second. Alright, so there's our equation, and as I said, we know that D equals 5, but we don't know what I and I naught are. But we know the intensity of the light is halved, and I've mentioned before that I naught is the light at the start, so the light at the surface if you like, so I naught. Okay, light at surface, so the light intensity at the surface to be exact. Okay, and I equals light at d meters. Alright, so we know the light is halved, so it doesn't really matter. If I call, for example, if I call here the light at the surface 10, then the light halfway down is 5. If I called it 12, the light, sorry, not halfway down, the light at 5 meters down is half, so it'll be 5. If I called the light at the surface 30, the light 5 meters down is halved, it's going to be 15, and so on. So it doesn't really matter, because what's going to happen here, and say I do call it 30 and 15, it means that 15 equals 30 e to the minus k times 5. And when I divide through by 30, okay, I get 0.5 equals e to the minus 5k. And it wouldn't matter if I chose 15 and 30 or 10 and 20 or 5 and 10. Okay, I know the light is halved at 5 meters down. So whenever I divide those numbers, I'm always going to get 0.5. So whatever the light is at 5 meters down compared to the light at the start, when I divide them I get 0.5, half the light. So now I can put that in the calculator. Solve. 0.5 equals e to the negative 5k, comma k. And that gives me a value of k of 0.1386. 1386. Now I've got to write the equation substituting the value of k. So I equals I naught e to the power of negative, sorry, not negative, the power of 1.1386d. So what I've done there is substitute the value there for d. And we can use that equation from here on. Next question says, find the percentage of light available at a depth of 10 meters. What I've got to do here, if I want to find the percentage of light will be I over I naught. That is the light intensity now divided by the light intensity at the start multiplied by 100. That will give me the percentage of light available. Now, before I can multiply it by 100, okay, I'll have to find that ratio. And to find that ratio, it's going to equal e to the power of 0.1386d, and d is 10. So I over I naught equals e to the power of if I multiply that by 10, 1.386. And if you do that, you actually end up with a ratio of 0.25. Multiply that by 100 to get it as a percentage, we get 25%. Next one, if artificial light is necessary when the intensity of light is less than 0.1 of its intensity at the surface, find how deep the diver can go before artificial light is necessary. Okay, so here's our equation. So our ratio once again, okay, equals that. And this time, oops, not D, T. And this time we're trying to find D. Okay, we're trying to find D. And we're looking at 0.1. Okay, so the intensity of light is less than 0.1 of the intensity of the surface. So we're looking at when, what the distance is when that ratio, I over I naught, that is the intensity at a certain depth over the intensity of the surface equals 0.1. Alright, let's just go to the next slide. Now I've been using the calculator here a lot. I just thought I'd change it up once again and show you how to use that log way of doing it. And remember, to use the log way of doing it, you log both sides to the base e. And if we tidy up this other side, we bring that out the front. Multiply it by log e to the base e, which is 1. Okay, so we would get 386d. So moving up here, we've got log 0.1 to the base e equals d, and we can divide over this side by the 0.1386, and the d we get, the distance we get there, is 16.6 metres. There we go, long video that one, but hopefully that's given you some idea how to do the modelling questions. And now you can have a go at exercise 3i. So exercise 3i.